reasonably quietly for me? We're okay? Can you hear me? Isn't it crazy? Anytime people ask you, can you hear me? Then, of course, if you can't hear me, then you can't answer. Let's see. So it's great to be here, and I've had a great visit last night. You put me up at the Bottomley House, and that was very nice. I was away from Cleo, our 3-year-old Labrador, and that was a relief for me already. So I appreciate it. And then I had some very terrific conversations this morning, including with Glenn and with the president and with some of your faculty. So I wanted to talk with you today about something that I think is incredibly important for American science, and that has to do with diversity. And I'm going to try to do something that's very difficult for me. I've never done this before. The second part of my talk, I'll be talking very personally about my own life. And I do that not because I happen to work at Howard Hughes. It's just about me. So I hope that you'll be able to discriminate between sort of the official perspective and a more personal perspective. In neither case am I trying to be prescriptive. So we're in this awkward situation where my group happens to give the University of Richmond a grant for all the good work that you do here. This has nothing to do with how we want you to spend your money or what we think you're doing or not doing with our money. And nor does it have anything to do with the proposal that is being reviewed now, which we're in the middle of it, and I actually have no idea how well it's doing. So I wanted to talk with you today about sort of a perspective. And before I go there, I was just going to make a couple of points, and this is why I enjoy my work so much at Howard Hughes. As April said, I've spent a lot of time on the faculties at Purdue and at Harvey Mudd. I've only been at Howard Hughes for about 3 years, and I'm one of these people that's the glass is half empty kind of a thing. So it's really hard for me to say this, but I'm beginning to enjoy my work. And the reason that I enjoy it is for a number of reasons, but it should come as, I'm going to say a couple of things that are absolutely obvious to this group. The first is that the undergraduate time is just a key lever point, I think, for American science. You know, for those of us who have taught undergraduates, I'm sure that we've heard people, nobody in this room, but certainly people will say, you know, I could do a better job teaching if those students who are coming out of high school were better prepared. You know, I'm such a great teacher, but I'm limited because of who's coming to me. It's not my fault. It's, you know, whoever is teaching them in high school. And for those of you who have trained graduate students, you've heard the same thing. You know, I'd really love to take a bunch of graduate students, especially from this country, but, you know, the reason I've got to go and find international students is because, frankly, you know, these undergraduates that are coming out of American colleges and universities, they're just not good enough to contribute to my lab. Well, of course, every graduate student was once an undergraduate, and every teacher was once an undergraduate. And so I think that it is an important responsibility of undergraduates and those who teach undergraduates to model good science education. Now I learned how to do animations. One of my group showed me this a few months ago. I'm not going to bother to go through this, except that I'll just quickly tell you that that purple circle is meant to represent the population in the United States. This is drawn approximately to scale, and so what I would tell you is that there are about 50 million kids who are in K through 12. Some of them become undergraduates. There's about 20 million undergraduates at any time in this country. And some of those undergraduates then become physicians. Some of them become scientists and engineers. And some of them become teachers. And so this is the feed-forward part, borrowing something that Bruce Alberts talks about, feed-forward and feedback. So this is the feed-forward part. But of course, the responsibility for us also has to do with the feedback. And so the teachers, if we model good teaching, if we model good education, then we can expect good teachers to prepare students. The other thing that I wanted to talk about has to do with selection versus development. This is an outstanding institution where we are today. You know all about selection. I think some of the admissions folks are here, is that right? So clearly, our job is to select the very best students as we define them. But I think it's important, and Howard Hughes has made a very concerted effort to emphasize this, that what we are about, what we should be about, is about the development of the students who come to our institutions, as opposed to just a selection. And so if you plot the number of students versus achievement, no matter how selective you are, you're going to get a distribution. And so there will be a distribution of students, and here they are. And of course, we're always interested in the students who are at the far right of this curve. But I would challenge us to think beyond the selection of students who have shown some sort of achievement and try to figure out who amongst our students has the potential for success. And the reason we give grants is to encourage institutions to develop their students so that they can begin to look at the potential of their students and to identify the students who can be developed within your institution. Now, I really love a lot of the things that we do, and certainly one of the initiatives is our grants that we give to small colleges. This is a large small college, but you're still part of the small colleges thing. And as you heard, I've worked for a long time at Purdue, and I worked at Harvey Mudd. At Purdue, I was the best teacher they had there. I had all the teaching awards. I'm a member of the Academy of Great Teachers. I'm on the wall, on the book, or whatever it is, of great teachers. I have the awards. So after 19 years at Purdue, I went to Harvey Mudd, and I learned all about teaching for the first time. And that's because large schools and small schools are clearly very different. And what's beautiful about small schools, and I'm going to give you some numbers here in a minute, in addition to the impact that you have on science, it's a disproportionate impact. In addition to that, we don't have to make the argument with you that dealing with your undergraduates is important. You already get that. So when I worked at Harvey Mudd, it was clear that all of the faculty there already cared about their students. We didn't have to convince them that this was important. And so that's why, and that's the context in which we're going to talk about diversity today. But just a couple of numbers. You might know this already. But small schools, the primarily undergraduate institutions, produce about 18% of all the baccalaureates in science and engineering in this country. And yet the impact is disproportionate to the rather small number of students that you produce. Now, there's something called the Overland 50. When the Overland 50 were first created, the University of Richmond didn't qualify, but you would be part of that. But the Overland 50 are the leading liberal arts colleges in the United States. The very high research universities are the schools, that about the 197 top research universities in the country, all primarily undergraduate institutions, high research universities, and the doctorate universities. And so here, this is just NSF data, looking at the number of doctorates in science and education per 100 baccalaureates. And what you see is a disproportionate impact of the small, primarily undergraduate institutions, especially those that think about liberal arts. Here's a different way of saying the same thing. About 13% of the science and engineering baccalaureates in this country come from primarily undergraduate institutions like this one. So I was wrong. It's 13%, not 18%. And yet if you look, for example, at the class that was elected to the National Academy of Sciences in 2010, those who were educated in the United States, 32% of them have their baccalaureates from small schools. If you look at Nobel laureates in chemistry and physiology or medicine since 1950, 28% of those who are American educated come from small schools. And so people have speculated, of course, about why small schools have a disproportionate impact. We don't know. It's hard to do the experiment. It's hard to control for that. But certainly, if we were to speculate in an intelligent sort of a way, I would suggest that part of the reason, there's probably at least two reasons. One is the emphasis on student learning that goes on a more individual basis at a small school. That's why faculty work here. And that's probably different than at a research university. And number two, it has to do, I think, with the ability to integrate the disciplines at a small school, a much more liberal arts approach to learning science. Okay, so that's part of the reason I love my job. So now let's talk about the hard problem, and this is really the rest of today's talk. So the hard problem that I want to talk about today is not only a hard problem, but it is essential for us to figure out the answer to that problem for the future of American science. I know April talked with probably a similar group last week, and so I'm not going to spend a lot of time giving you data, but I think that you understand already what I'm saying. So we're going to talk about diversity in science, and indeed, I'm going to limit my conversation today mainly about race. Now, diversity, of course, is something that we understand and that can be defined in any number of ways. Diversity can be by discipline, by height, by gender, by race, by sexual orientation, by nationality. And all those things are important. But I'm going to talk about race today, mainly because for scientists and academics, I think race is the hardest thing for us to talk about. At least that's my experience. And frankly, when I think about how I identify myself, I think about my race. And so that's where the personal part of this comes in. So I asked myself, well, so why do we care about diversity, especially in the context of science? And I think that there are a number of reasons, but I came up with three. The first has to do with equity. You know that in the 21st century, students who are coming out of their student time and they're becoming adults have to be able to engage in science and technology. If you want to have any kind of power in this society, you better understand at least something about science, mathematics, and technology. Whether you're thinking about your health care, or you're thinking about the environment, the climate, whether you're thinking about information or communications, energy, all of those things, of course, have a lot to do with science, technology, engineering, and mathematics. And so I think that just as an equity perspective, it's important for us to make sure that all people in this country have the opportunity to be full citizens. Well, the second reason that occurs to me, and I think April probably talked a lot about this, is the Willie Sutton paraphrase, which is that diversity is important for science because that's where the talent is. And it should come as no surprise to you that the United States population is rapidly changing. And if we're interested in advancing science and continuing to lead in science, it's important for us to tap into the entire talent pool. And this is why Howard Hughes is very interested in making sure that we grab all of the talent available to us in this country. Today, the United States population has about 32% who are underrepresented minorities. 44% of school-age children are underrepresented minorities. By the year 2042, so in 30 years, we will be majority minority, and by the year 2050, the population will be 45% underrepresented minorities, and more than 60% school-age children will be underrepresented minorities. So if we're serious about grabbing hold of all the talent is going to look a whole lot different than it has in the preceding years. I don't know how many of you have had a chance to see this report. It was released just a couple of weeks ago, the PCAST report on undergraduate STEM education. They make 5 recommendations in this. And the title of this, I think, calls us points out the challenge that we have in science. It calls for 1 million more students coming out of college who are STEM educated. They don't all have to become PhDs in science. They don't all have to become physicians or engineers. But this idea that we need 1 million more in 10 years than what we are now producing who are STEM literate. And so if you think about that, what that means is that we as a country need to find the talent that will, and then we who work at schools need to educate those folks at a rate that's much greater than what we are doing now. It turns out that overall, nationally, of all the students who enter college and university with an interest in STEM, only 40% graduate in STEM. This is whites, blacks, Asians, doesn't matter. 40% nationally. So that means that our business model says that we're going to take all of these students who are interested, they say they're interested in science, and we're going to make sure that at least more than half of them don't make it through. Now, I realize that we don't intend to do that, but that's what's happening now with our current business model. I'll show you some numbers later that, of course, shows that the underrepresented students do much worse than 40% in terms of staying in science. It turns out that if we, as a country, were able to increase the number from 40% to 50% in terms of retention of those who are already interested in science. You don't have to convince them that science is cool. They already want to do science. So if we can increase as a nation from 40 to 50%, over 10 years we will have reached 750,000. So even though 1 million more STEM educated students in 10 years is a big number, we've already got them in our classrooms. I think our challenge is to figure out how we can do better in terms of retaining half of them. So the third point is, why is diversity important? And I don't have any numbers here. I just feel very strongly that diversity is good for science. I think you already know that. We know that science is becoming much more complex. We know that in science, many of the low-hanging problems have been solved. Many of the low-hanging fruits, and maybe even the medium-level fruits, have been plucked. We know that the hard problems at the top of the tree are much more complex, much more derivative, much more interdisciplinary, much more at the interface amongst different ways of thinking about science. I just sat in on your IQS course today. Clearly that's an example where you are trying to engage freshmen in an interdisciplinary approach to solving a particular science problem. So I would argue, and I think the engineers have already figured this out, that the future of science and the future of engineering is when people work in teams, and that those teams, there's no point in having a team if everybody does exactly the same thing. So those teams have to be heterogeneous, they have to be diverse. And it's important then for students who are going to be engaged in science or engineering, it's important that they understand how to work in a diverse group, that they can value different perspectives. In fact, and the Supreme Court has been in the news just very recently, as I think many of you know, the Supreme Court has decided that they're going to hear the University of Texas Austin case, which has to do with affirmative action. Now, there are a number of cases that have come before the courts, and the two that we think about a lot are the Bakke case, which was the Bakke against the University of California Davis Medical School, and then the Grutter-Bollinger case, the University of Michigan Law School, which was just a few years ago. And in both cases, the Supreme Court upheld the use of race for educational purposes. But they tell us, the court told us why it is compelling and what are not compelling arguments. And indeed, if you read these cases, Justice Powell wrote the majority opinion for the Bakke case. Basically, he's saying that the equity argument, the argument that it's important that all of us be able to engage in leadership and be empowered in this country, is not a compelling argument for education. Sandra Day O'Connor went on, when she wrote the majority opinion in the Grutter versus Bollinger case, this is the Michigan case, that the compelling reason for diversity in education is exactly what I just said about diversity being good for science. That it selects those students who will contribute the most to the robust exchange of ideas and better prepares students for an increasingly diverse workforce in society and better prepares them as professionals. So even though I personally happen to believe in the equity argument, the courts are saying that in fact the reason that diversity is important for this country and in education in particular is that it's good for all of us. And I think that's a very good and important point. So how are we doing? If diversity is important and we're speaking specifically about racial diversity in science, how are we doing? Well, about 32% of the country is underrepresented minorities. It turns out that across the country, 28% of our undergraduates are underrepresented minorities. That mirrors very closely the US population. But if we look then at science baccalaureates, only 17% of the science baccalaureates are underrepresented. And if we look at science PhDs, only 9%. Why aren't we doing better? I would suggest that the data say that it's not because students of color are not interested in science. I would suggest that it is a lack of persistence on their part. And I further would suggest that it's our responsibility as faculty members to change that situation. Now, there was a very interesting study that was published back in 2000. And in this study, the persons who did the work looked at a large number of students in high school, and then they tracked them through college and university. The number was something like 17,000 students. And what they did was they looked at students and they normalized this population so that they could begin to eliminate some of the factors that we always assume. So they looked at the same socioeconomic background. They looked at the same educational background of their parents. They looked at the same interest in terms of college that the parents would communicate to their students. They looked at similar high schools. And so they're really trying to look at a comparative study. And so then what they did was they took these students. These are all students who were interested in STEM. They were all interested in science and engineering going into college. And then they simply asked what happened to these many students as they progressed through college. And they binned the results into 4 different places. Some students were completers. They completed the degree in the STEM discipline in time. In time meant 5 years in this study. Or a student could persist. So she might take longer than 5 years to get her degree, but she stayed in the discipline and she ended up with the baccalaureate degree. Or she might switch to another discipline, but she still graduates from college, and then finally some dropped out of college, university altogether. So if you look at these data, there's a number of different ways of looking at it. I'll just call your attention to these up here on the top. So we've got the 4 bins, the completers, the persisters, the switchers, and the dropout. And we're comparing the whites and Asians at the top and underrepresented minorities in the second row. And so the first thing that strikes me is that the dropout rate is essentially the same. So underrepresented students are not dropping out of college in this population of students, but what the difference is that the number of students who are switching out of STEM is more than twice the rate that the majority students are, and the persistence rate is much lower. Now that's a 2000, a year, the study was in 2000. Sylvia Hurtado, I should say this is my Ben Franklin thing. This is my favorite quote from Mr. Franklin. There's a number of different ways of saying this, but we must hang together or surely we shall all hang separately. And my point is that we are not hanging together. Those data suggest that as students come into college with an interest in STEM, they're becoming fragmented. And some are persisting and some are not. And I think it's our responsibility to do a better job. Now, this is the report that came out just a couple of years ago. This is the National Academies report chaired by Freeman Hrabowski. The same sort of data are here. And this is, I think, a rich place to look at these sorts of things if you're not already familiar. Now we're looking at 5-year completion rates in STEM. It's broken down by race. So you have whites, Asian Americans, Latinos, blacks, and Native Americans. And what you can see is that for the majority students, they're doing about 40% are staying or finishing up in the STEM disciplines after 5 years. And the underrepresented students are at about half that completion rate. That report also talks about non-STEM disciplines. And for me, this is a very interesting and I think very meaningful piece of data. So in blue are the students who start off in STEM. In red are the students who are not in STEM. And no matter what their color, you see that in STEM, we're not hanging on to our students as well as our colleagues in the non-STEM disciplines. So I would suggest that there is something about the way we teach science and engineering that is driving more students away from our discipline than first this country can afford, and second, it's at a greater rate of driving them away than our colleagues in other disciplines. And it doesn't matter what the color is. It's just exacerbated if you're a person of color. So for Howard Hughes, what this means is that the reason that diversity is important for us is because we want to take advantage of all of the talent pool, and we believe that a diverse group of scientists will be able to solve harder problems better. And if we can do it at a better, if we can do better in terms of persistence of underrepresented students, I would suggest that it will be then, we will then be doing well for all students. And so this canary and all that sort of stuff. Okay. I'm going to pause. Is there any question about what I've just said? Because I'm about to go away from the less official, the more official sort of perspective. Yes?
I'm just a little troubled by your statement that the way you define race, that there were characteristics that were sufficient enough to categorize people. So I'm a political scientist, so I'm not a real scientist. You know, we're fakes. We just play ones on TV. But I have a little bit of trouble with that because that's, I think, part of the problem is that when you think you're looking at a category of a human being, then for African Americans, there's a certain group of very negative assumptions that are then attached to that person. And I'm not sure that I'm not sure that you do have sufficient, you know, evidence or inheritable characteristics to categorize blacks. And I say that because as I travel out of the country, I always have to prove to people that I'm actually African American. Everybody, everywhere thinks I'm white. Because they think, you know, typically I do not look black. I don't have that problem here in the United States, especially in the South. We understand that lots of people like me walking around. But you know, we also talk about race being socially constructed and having no meaning scientifically. But that's the other thing I kind of want to ask you. Is there a meaning scientifically that is not talked about, or that you guys don't want to talk about, that makes it more salient than we in social science want to believe it is?
Yep. So you've said a lot of good things there. And so the first thing that I would say in response is that I am not a social scientist. And so I don't appreciate the nuances of race as you have talked about them. My slide was just from Webster's dictionary. So I just used that because I wanted to talk about race as I understand it. Now, the other thing that you said that's very important is that we want to, and I should have said this, but we want to be very careful when we talk about diversity and perhaps racial diversity, in that I think it's really important that we understand that every individual comes to a school or comes to her, whatever she is doing, with a number of different identities. And so although I'm just talking about race today, it's not just talking about race, but I'm talking about race partly because when us scientists talk about these things, race becomes a particularly difficult topic for us. And what I've noticed is that we quickly go off and we talk about other forms of diversity, which are also very valid. So it's terribly more complicated and terribly more complex and terribly more interrelated and interconnected than I'm trying to make it out to be. But for today, I simply wanted to talk about race. You know that you've all probably done this exercise where you would take a group like this and you would spend the first 15 minutes brainstorming with a pad of paper, and you'd say, tell me all the different characteristics by which a person can identify him or herself. So people say, well, my sex, my religion, my nationality, my age, my height, my eye color, my race, what state I grew up in, whether I went to a public school, private school, blah, 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 right? So with a group like this, we would end up with 50 sheets of paper in about 5 minutes. So then the exercise, right, is that they're sticky kinds of pieces of paper. So you put them up on the wall. And then you say, okay, we've got about 50 people in this room. Go to the sign that's your first criteria, your first characteristic, your first way that you identify yourself. And so people will usually just sort of stand there to look at all the different signs and say, well, you know, it's more complicated than that. I am a complex person. I identify myself by my religion and by the state I grew up in and by my race and by my hair color and so forth. But you ask the people again, no, go to the one that's the primary way that you identify yourself. All right, so people sort. And then you talk about it, and then you say, okay, now go to the second. People sort. And usually there's a group who stand in the middle, who they can't do it, because it is too complicated. So I think I get it, and I appreciate your comment. That's what I'm limiting myself today. And indeed, in terms of American science, we are fairly simple. And we do have to think about these kinds of categories, if you will, that don't do justice to the personal identity that people have. I agree. I understand. Other questions or comments? Yes, Eugene.
David, I came across a New York Times article recently, and basically it said that across the board, students were dropping out of STEM and moving to a different field because simply science is too hard. But science is hard. That's something we should appreciate. It's highly technical. So, you know, is there a good solution to like either making science less hard or getting students to appreciate the hardness of science?
Yeah. So, I mean, for you, chemistry is probably a lot easier than it was for me. And so I get it that is a reason that people talk about. I guess what I'm trying to say, and what I'll try to end with today, is that no matter what the rationale for why students leave, I think it's incumbent on us who are in the profession of educating students to just do a better job in terms of making it so that they can understand whatever we're trying to teach. And I'm going to tell you sort of my personal perspective on that. But that doesn't mean that you make it easier or you make it harder. I think for where I'm coming from, I think it was really important for me to try to understand that every student in my class comes from a different perspective, has different sets of values, and probably learns differently. And so it's important that I try to understand that and respect that and produce enough room in my classroom so that different learning behaviors, different styles, all that stuff can be acknowledged. And I don't, I mean, that sounds very simplistic, and it is. Part of my job here is to be fairly simplistic. So, okay. So I want to spend the last few minutes telling you more of a personal story, and it has to do with. I'm going to put this in the context of what Eugene just asked, which is, how do we begin to solve this very difficult problem? And I'm going to suggest that the way we solve this problem is not just the way the academic community often solves problems, or we try to solve problems. It's not just that we appoint a committee or have a task force, give a grant, have a vice president for some special category. That's what we do, right, in colleges and universities. So I think those are all important, and I know that there are administrators in this room, so I'm being very careful about my words. But I'm going to suggest, I'm just going to tell you what worked for me. And it wasn't a committee, it wasn't a grant, it wasn't a task force or a brown bag lunch or anything. It wasn't a talk like this. It was much more of a personal voyage. And so I need to tell you a little bit about that personal voyage. And I identified sort of 3 stages in terms of how I've gotten to where I am today, without suggesting that I've perfected any of those stages. But the first stage for me was just being aware of my race, being aware that I'm different than many of the people around me. I'm going to start off with my father, because his story is very interesting. So I was raised Japanese American. I'm Sansei, meaning I'm 3rd generation born in this country. My father's Nisei, 2nd generation. That's actually a picture. It's on the cover of a book about East Los Angeles. This is the only picture I have of my grandmother. And these are her 2 children and the 3rd kid who nobody knows. But this is my father when he was a little boy. Now, my father was born in 1914. And he was born in Los Angeles. And when he was in high school, about 15 years old, his family moved first to San Pedro and then to Terminal Island. Now, for those, so who knows Los Angeles? So Terminal Island is where? It's an island.
I know Palos Verdes.
Palos Verdes, yeah. So it's Long Beach is right there, right? So Terminal Island is now where all of the shipping comes in. So if you go there now, if you want to ship your car to Hawaii, you have to go to Terminal Island because that's where the piers are. So back then, back in the 1920s and 30s, it was a small population of about 300 families of Japanese Americans who were mainly fisher people. My father's family happened to be in the dry goods business, and so they were serving people who were fishermen. And so back then, there was this little community, all Japanese American, fishing because, of course, it's a good place to go fishing. When World War II came in December of 1941, this was one of the first places to be evacuated because of their race. Now, I should back up and just say that my father's parents, so these are first-generation Japanese American, could not become U.S. citizens, could not own land, could not marry anybody that they wanted to. They had to marry within their race because of their race. And then when World War II came, about 110,000 Americans, 2/3 of them were U.S. citizens like my father, who were born in this country, so you're a U.S. citizen, were evacuated from the West Coast. And he was put into, there's my dad actually. So just on Saturday, I went out there to see him. He's now 97 years old. So we went to Terminal Island and looked at the memorial there. So he and his mother and his sister were put in Poston internment camp, which is right here between California and Arizona. It's in the desert. He was then relocated to Albion, Michigan, where now you understand that by 1941, 42, my father was born in 1914, so he was already a young adult. He'd already gotten his bachelor's degree at UC Berkeley. He already had his business degree. But because of the war, they lost everything, and so he became a janitor at Star Commonwealth for Boys. And then eventually he went to Andover Newton Theological School to become a Christian minister. He was raised Buddhist, but he decided he would do this. He went to Andover Newton because this was the only seminary that would take him. So he's a Christian minister. He's retired now, obviously, but he then spent a lot of his time in the congregational denomination working for small churches in the New England area. And if you know anything about the congregational denomination, you know that this is sort of a democracy, a local democracy. So they get to vote on their own preacher, they pay their own preachers, there's no bishop and all that kind of stuff. And so, frankly, he went to churches that could afford him. And he wasn't, you know, again, defined by his race. Now, I came along, and my first home was in Vermont. I'm adopted, so I'm actually Korean. I'm biologically Korean. So I was adopted into this Japanese-American family, and I grew up in a couple of small places. I started off in Vermont, and then I moved to Kansas. In both of those places, we were really the only non-whites in the community, and certainly one of the very, very few non-whites in the county. In school in Kansas, this is where I was from the first grade to the fifth grade. It was a very small school. There were only 13 kids in my class. There were 2 boys, me and Jim, 11 girls. When I left in the 6th grade, it was just Jim, so he's done well. But you know, I remember one thing that happened in Kansas. There was a young guy, a couple years older than us. His name is Doug. Doug was shorter. He is of shorter stature. So he made it his business to bully other kids, and he would bully me a lot because of how I looked. And so he would make fun of me in the locker room, and he would call me, you know, he would use, you know, he would say, you know, Ching Chong Chinaman, or you Jap. This is back in the 60s, and so his parents still remembered World War II. And I always thought it was ironic because he was calling me Chinese or Japanese, and indeed I'm Korean. But the other irony is that Doug lost his life in another Asian country when he was drafted into the Vietnam War. So this was my, you know, up until the 6th grade, this is sort of my beginning to become aware of everything. And I'll just add one more little thing. For those of you who know a little bit about Asians and Asian Americans, you know that Koreans and Japanese pay a lot of attention to that difference. So anytime my mother would have a fight with me, which was quite frequent, she would remind me that I was very fortunate to be growing up Christian in a Japanese household. So these are just things that, you know, we're percolating. So when I was in the 6th grade, we moved to Maui. And in Maui, it was a much bigger place. There were 30 kids in my class, and it was almost all Asian. In fact, there were only 1.5 Howleys in my class in the 6th grade. Edward, who was, you know, a white guy, and Naomi, who was Hapa. And so now I'm seeing it from this other side. And so again, this was just part of my own personal awareness. All right, so the second stage of my development occurred when I went to Stanford as an undergraduate. Stanford is an elite university, as you know, and they take great pride in their eliteness. And so I would characterize this as my intellectual activism stage. And it was at Stanford that I learned about the history and the culture, the language, the literature of Asian America. I learned it from a number of people, including these 2 people, Edison Uno and Pat Sumi. In typical Stanford fashion, I should say, that I learned all of this, taking classes from these folks, not for credit. And in fact, these folks were not faculty members at Stanford. They were from San Francisco State. Stanford wouldn't hire these kinds of people. But I learned a lot about my identity as an Asian American, very intellectual, right? Very, you know, a lot of history. You can name all the dates, all this stuff. I collected books. The other day, I pulled off some of these off the bookshelf. I have over 100 books about the history, literature, culture of Asian Americans. So this is an intellectual sort of ownership, if you will. The last thing that ended that phase of my learning happened at graduation from Stanford when I was getting my bachelor's degree. The commencement speaker was this gentleman, Daniel Patrick Moynihan, the iconic liberal, later was a senator and all that good stuff. And Moynihan, for those of you who remember this history, prior to when he was our speaker, had written stuff, and he had talked about the African Americans in this country. He had acknowledged that slavery had been a terrible burden for 4 centuries, but his solution really argued that minorities needed to pull themselves up by their own bootstraps, that it was more blame the victim, it's the victim's responsibility to make herself or himself better, that society didn't have much of a role in that. So those of us who were activists back at Stanford, we walked out during graduation. This was very difficult, by the way, for my parents who just came from Hawaii. And it was the first time they've ever been at Stanford, because we're not very rich, and so they didn't get a chance to visit very much. So they're at Stanford, right? And it's a big, open amphitheater, and all of a sudden, all of the brothers and sisters got up, and we walked out. And my parents, never mind. Okay. So the third thing has to do, my third stage, if you will, is what I'm going to call emotional ownership. And this is where I think some of the solution to at least how I think about these things comes from. You can be aware of race. You can be aware of your own identity. That was my first phase. You can take an intellectual, even an activist perspective. So you get all the books, you read, you take all the classes, it's up here, right? But the third thing I think has to be here. And I believe that nothing that we do with any passion, with any kind of energy, can happen without some emotional ownership, regardless of what the problem is. And so this happened when I was at Purdue. Sally Frost Mason was the provost at the time. She's now president of the University of Iowa. And she began to fund forums in which faculty, first from the schools of engineering, would take part in these 2.5-day forums in which they would talk about identity, they would talk about race, they would talk about just sort of the relationships, and they would eventually get to the point where they would hear from students about how it felt to be in the classroom. And so Sally was funding these things for a few sessions. And Harry Morrison, who was our dean in the School of Science, was asked to go to one of these forums. Now, Harry's an old chemist. He's still there. He's 75 years old. He's no longer dean, but he's still active. And, Harry, he was a great dean to have. So he went to one of these forums. And then he came back. And at that time, I was department head. So there were 7 departments in science. And he sat us all down in typical Harry fashion. He said, OK, I just went to this great forum. You're going to go next. And I said, well, why, Harry? I mean, this is 2.5 days of my life. I'm a busy guy. I got a big department, all that stuff. He says, you're going to go. And I said, well, Harry, what did you learn at this thing? And he said, oh, David, I didn't know this, but did you know that many years ago the United States put Native Americans into English boarding schools so that they would break them of their culture? I said, Harry, I knew that. He says, David, you probably know this, but did you know that during World War II all the Japanese Americans were... Harry, I knew that. He says, David, did you know about Jim Crow after, even after the slave... I knew that, Harry, so why should I go? He says, David, you just go. So I went, and I went to the forum, and I was transformed. I was transformed not because we came up with the solutions. You can't come up with the solutions. But because for 2.5 days, me and about 50 colleagues from science and agriculture, faculty folks, sat around talking about a hard problem, race. And I think we ended by trying to understand how it feels to be privileged, how it feels to be in my classroom. One of the things that happens at the end of the forum is that graduate students and undergraduates who are now alumni, who happen to be underrepresented minorities, come back and they tell us what it felt like to be in our classes, in our labs. And you know, that's very important. So we didn't solve anything, but I learned something. So anyway, I then moved to Harvey Mudd. Maria Clave is our president, Bob Cave is our dean. And these folks said, well, okay, this sounds good. So I took 7 of my colleagues back to Purdue. We sat in on the forum again. This is my second time. They all came back and they said, yeah, we got to do this. Harvey Mudd's a very small school, much smaller than this school. So we were able to then run 3 forums at Harvey Mudd, in which we basically got every single faculty member and every single senior administrator to participate in at least one of these things. So in the last minute, let me just tell you what I think I got from those 5 forums that I've been part of. Each of them is 2.5 days. I think that by engaging in something like this for that kind of length of time on a topic that's so difficult to talk about, I have a much better understanding of my colleagues. At Purdue, I didn't know half of these people, right? It's a big place. At Harvey Mudd, I knew them all, and yet I didn't know them until we did this. Second is a lot of the things that is emphasized in the forum has nothing to do with fixing the race problem. It has to do with how we communicate, how we listen. And so there are a number of exercises in terms of listening that I still use today with my own group. I just need to learn how to become a better listener. And finally, and this I think was where the heart becomes a major part of this, I think that we began to see a much better understanding of how students in my classroom learn. And in fact, at a small place like Harvey Mudd, where the faculty are already there because they care about the students, this was a profound impact on our faculty. So I'm going to conclude with 5 points. What I've tried to say today is that diversity is important because it's good for science. I've suggested that a key point in terms of when we do this is at the undergraduate stage. I think that it's important that we as a nation figure out how to improve persistence of all students, and in particular, students who are underrepresented in the sciences. I think that it's the faculty who have the responsibility. And finally, I think the where is that a lot of this has to come from the heart. So I appreciate your time. I know that I've run over, but I'm happy to talk, take whatever questions or comments you might have. Thank you.